Hello and welcome back to the course on artificial intelligence. In today's tutorial, we're going to have some fun. We're going to have a look at an artificial intelligence actually going through that maze that we've been talking about so long, and is going to use Q-learning to navigate its way and find the way out. And we'll see what happens to the Q values, what's going to happen to the policy, and so on. So let's have a look. We're going to be using some materials kindly provided by the Berkeley University. So if you go to ai.berkeley, berkeley.edu, if you just go to that link, click enter, you'll see this website. And here, what we're going to be looking at is you need to go to, where do we need to go to? Pacman projects, I think. Yeah, Pacman projects. And here, if you scroll down, and you look at reinforcement learning, this is what we're working with. So here you can download the zip archive. So that's if you want to. So you don't have to. We're not going to go through the solution together in this tutorial. I'm just letting you know where this is all from, because we really appreciate that UC Berkeley has made these materials available. But if you do wish to experiment with this on your own, just bear in mind it's not going to be part of our course. This is part of the Berkeley course. I'm just going to show you how it works for illustration purposes. But if you do want to experiment with this, you can find it here, the zip archive and all the instructions as well. And we're just going to go into Python right away. And first thing I wanted to show you is that here we've got the licensing information. So this is what I mean. We're very lucky that they said we are free to use or extend these projects for educational purposes, provided you not distribute or publish solutions, which we're not going to do. You retain this notice, which we have, and you provide a clear attribution to UC Berkeley, including a link to which we also have. So once again, if you'd like to learn more, there's a link. You can have a look. And thank you very much to all of these people who have worked on this project. So here's the grid world that we're going to be working with. There's a solution there. You would have to, in order to make it work, you'd have to either solve it yourself or possibly find a solution. Maybe somebody you know might help you out with that. If again you want to, you don't have to, because we're just going to look at it on this screen right now. So after we've created all those files, we can just launch it over here. So there are some parameters that are involved in this whole world. And now I'm going to just show you what it looks like if we launch it. So let's try launch it in manual mode. So if I go -m, one of these parameters here, manual. So I can manually control the agent. So here you can see our grid. So I can go up. So you can see that it's taking action, started in state, so where I was. And then you saw that I pressed up, took action north. And first time I ended up in 0, 1. So I did go up. But second time I took action north and I ended in the same state. I didn't move. So something happened, the randomness happened. I either went left or right. And by default, the parameters are set. You can see here by default, they're set to exactly what we discussed, that how often action results in unintended direction 20% of the time, 10% to the left, 10% to the right. So if I go up, you see I went up, I go right, I went right, no, didn't happen, right again, and right, and I'm finished. But in this implementation, you have to click again to get out of this final output. So out of the exit, just click again and you're finished. That's a terminal state. So we can run again manual. You can see that if I go right, left, up. So here, what we saw previously, that the agent wouldn't go straight up, right? What's the point of going up if there's a chance of going into the pit? So let's see what the agent would do. It would go left. It would go west here. So it would go west. And you see I clicked left, but it went up. And here I would click right and I end up in the final exit state. And you can see it got reward equal to 1. So that's what it looks like manually. Now let's actually hook up an AI to this and let it go through this. So let's do an H here and let's add some parameters. So let me just see what I typed here. So hopefully you can see Python gridworld.py. Then here -r means that's the reward for living. So I've got my 2 of them, so I probably should remove this one. So -k is how many iterations. That's way too many iterations. Let's do less. Let's do like 10 iterations. That should be enough. -a is agent. What type of agent I want to do? On a random agent, some value agent, or a Q. So I want a Q learning agent doing this. -s is, what is S? Speed. So that's way too fast. Let's just use default speed for now. -r is the living penalty. So by default is 0. So remember at the very start we started with 0 living penalty. So let's call it also 0 here, or we can just remove this parameter. And D is, what is D? Discount. So our discount factor, so let's keep it at 0.9. So very similar to what we were starting off in this section of the course. So let's run that. Okay, way too fast again. Oh, actually it's so pretty okay. So you can see how he's exploring. And so far he's hit the -3 times. And you can see how the Q values are being updated in these squares. So these are Q values. They start with 0. You can see now the Q value. So he's learned that, again, this one is a bit differently implemented because once you get to the final stage, you have to get out of it. You have to just click one more button to exit. And so it's very close to 1, but not exactly 1. But at the same time, you can see that here, the value is slowly kind of crystallizing in 0.8, it's slowly getting somewhere. But the rest, so far, they're kind of zeros because he doesn't have enough information to understand what's going on. Okay, so let's see what happens here. Exploring. What's going to happen? Whoa, it's been a while. And don't forget, there's some randomness involved here. So there's hit that good one a few times now. He only gets 10 iterations, so he's got to learn fast. Okay, nearly there. Let's see what's going on. Come on, get out of that maze already. And yes, 10 episodes. So average returns, that's we're not really interested in that. So here, let's see. I've never seen that before. If I click right, there we go. So you can see this is the policy that he came up with. Even through just 10 episodes, he's already got a policy. Okay, I'm going to go bum, 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 bum. And here I'm going to go down. Here I'm going to go down. Here I'm going to go into the wall. And then I'm going to bounce over here. That's pretty cool. Okay, so now let's increase the speed. What was the parameter S there? And let's like double. Well, let's quadruple the speed. And let's increase the number of iterations. So let's say 20 iterations this time. And let's see if he can get through a bit more now. So you can see he's going a bit faster and he's learning that it's not really, out of this state, there's not many good actions, or, these actions that right and straight are not that good. Definitely, this one's definitely not good. He still needs to learn that. So from here, it's also not good. You can see that this action is pretty good. All right. What did he get? Okay. So interesting policy here. He decided to go up. Just not enough information. So let's redo that. And let's increase the speed to like 100. So it's super fast. And the number of iterations, will give him 100 iterations this time. Let's run that. See, the C is like crazy fast. And you can see that because there's so many more iterations, he's got more information, more opportunity to experiment and to actually build out this matrix, or not matrix, these Q values for every single state he now knows. Okay, you can see that 0.89. What did we say in our example? It was like 0.86. Another thing to remember that the value of any given state, remember that formula we had, is the maximum of the Q values. Remember that thing that we came up with, shortcut formula? So what would the value in this state be? The V of this state. It would be 0.89 because that's the highest out of the 4. Here, the value of this state is 0.71. The value of this state is 0.61, and so on. So that's something to remember. So I remember in our example, I think we had like 0.86 or something, so pretty close. And so if we go next here, oh, it just disappeared. Where did it disappear? Let's do it again. And let's make it come back. Okay. Slowly filling up some spaces. I see. And it's also pretty random because not only the environment has randomness, but also the way he explores at the start when he doesn't know the policy is he's exploring at random. It just keeps disappearing. I don't understand why. Anyways, let's see what happens if we increase the number here and here. Should pretty much take the same amount of time if the speed doesn't have a cap on it. Okay, so you can see it's like he has more opportunity to explore things. Okay, let's see how it all goes. And you can see the values are converging. They go up and down depending, because there's some randomness and he might end up like in the pit, even though he goes like this way. But at the same time, they're slowly starting to converge to some sort of N values and Q values. Okay, probably 1,000 is a bit too much in terms of time. It doesn't look like the speed is proportionately increasing as well. So we might cut that part. I mean, like reduce the speed. Yeah, wow, this is very long. You don't have to watch to the end of this tutorial. I just want to experiment with quite a bit. So to give you some like examples of what we've been working through, but you get the point that it goes through all of this. It has some randomness, like randomness built into its behavior. So even when it has like a policy, it will still continue exploring. So it won't just like, once it has a basic policy, it won't just continue following its policy. It will still experiment with other variations once in a while in order to enhance its policy. Maybe it hasn't found the best policy already right away. Maybe it can improve the policy. And that's why even after so many iterations, you can still see some random effects. It sometimes jumps into random states, not just because of the randomness in the environment, but also because there is some level, like a parameter which you could control, which you could set up for your agent, saying that, you know, most of the time, 80% of the time, do whatever your policy tells you to do, but 20% of the time, you know, just have some fun, experiment and see what happens, and use that information that you gather to update your policy. Okay, this is taking way too long. Let's try that again. Yeah, so that's how the agent learns in different states. Maybe let's just run one more just out of curiosity. So is there anything else we can change about it? Iterations. Okay, let's have a look. Yeah, well, we could change the discount, for example. So in this case, we could say K minus 100 minus A, Q minus S to the minus R. Okay, 2000. So reward, we want to keep it, maybe let's keep it at 0.04, but let's say it again. Let's keep the reward at minus 0.04 every time. And then here we're going to say that D, the discount is not 0.9, but it's like 0.5. So it gets discounted quite a lot as you go through the game. So it actually, now it'll be incentivized to be closer to the finish rather than further. The states close to the finish will get high values. So you can see that the values is quickly drops off. It's not as green as it was before. So here you can see that this is the policy now. So it goes like that, like that, like that, like that. Very similar to what we saw before. Just probably the only differences from here is jumping straight into here. So that's that one. And okay, let's just run one more. This is so much fun. Let's just run one more. So K minus K 100, AQ discount, keep it as it was, original. So like just run this basic vanilla setup. Okay. It's going. Let's see if it will show us the policy at the end. Yes, we got the policy. Yes, good finish. So here we've got the policy. You know, this is familiar. Remember that time when we saw that the AI outsmarted the human, went boom into the wall to go there, and boom into the wall to go like that, to increase the probability. So there we go. That is an example of artificial intelligence in action. Very, very basic, simple Q learning. So no deep learning at this stage, but at the same time, it's already pretty smart. And I hope you enjoyed today's tutorial. And once again, thank you to UC Berkeley. And I hope you enjoyed today's tutorial, and I look forward to seeing you next time. Until then, enjoy AI.